Two roads, one running north-south and the other running east-west, meet at a point A. Let's draw that before we go any further. So we've got a north-south road and a west-east road, and those meet at a point A. Now remember, north, south, and then west and east always make the word we. So it looks like that. So at 12 noon, Tommy is 30 kilometers east of A. So Tommy is going to be here. And he's driving at 60 kilometers per hour due west. So he's driving this way along here. Romeo is 20 kilometers south of A. So Romeo is, say, here. And he's driving at 80 kilometers per hour due north. What is the shortest distance between them and the time at which this happens? So what we're going to be interested in is this distance here, and we want to find the time at which that happens. So if we think about Tommy, he's travelling at 60 kilometers per hour. So 1 hour means he'd go 60 kilometers, and 2 hours 120, 3 hours 180. So the distance he actually travels is 60t. Now let's think about the distance from A. When t is 0, he's 30. When t is 1, he'd be 30 over here, which we could call negative 30 since it's the other side to where he started. So that looks like this distance should be 30 minus 60t. And if we do the same sort of thing with Romeo, that's 20 minus 80t, because he's heading up here at 80 kilometers per hour. Using Pythagoras' theorem, that means that d would be the square root of 20 minus 80t squared plus 30 minus 60t all squared. Now, for this sort of question, it's really likely you're going to have the calculator available to you. So we want to have d dt equal to 0. And so we want to solve for that. So let's go and find that. First we want action, advanced, and solve, and 0 equals, and then we'll have d dt of our expression. So that's going to be the square root. Actually, let's just change the t's to x for this purpose, because it's then going to make it easier for us. So we'll say d dx of the square root of 20 minus 80x squared plus 30 minus 60x squared. And if we execute that, it gives us x is 0.34. So that means t is equal to 0.34 hours. So we should perhaps change that to minutes. So 0.34 multiplied by 60 gives us 20.4 minutes. Forgotten the number. 20.4 minutes. And let's do the 0.4 into seconds. So 0.4 times 60 is going to be 24, isn't it? So that's 20 minutes and 24 seconds. So we want this minimum distance now, so we just need to actually calculate that, where t is 0.34. So we've got the square root of 20 minus 80 times 0.34. Don't forget to square that. And then we have 30 minus 60 times 0.34. And let's not forget to square that either. And that gives us 12. So d min is equal to 12 kilometers, and that happens at 12, 20 and 24 seconds. So let's say 12:20 to the nearest minute.